That's a Texas Star, and it has 5 plates on it normally, and if you shoot them off, it begins to move around. Unfortunately, the plates are just a little bit too heavy for rimfire, so I'll have to bring my 9mm the next time I come. Welcome to Amateur Redneck Workshop. I'm Harold, and we got a whole different job to do today, one that I had to get the materials for and wait on. But what we're going to do is we're going to replace the lead screw on my Craftsman lathe. I got some new half nuts at some point, and I installed those a couple of years ago, and then here the other day I ordered some new half nuts and put them away for the time when I'd have a good lead screw. And my lead screw, right in the area where I guess you call it the sweet spot where you do all the threading, is those square tops are kind of sharp tops now on the threads. So I looked at Sears Direct, you know, because mine is sold by Craftsman, and I'm sure they supply parts for Atlas too. But anyway, I looked at Sears Parts Direct, and they had the lead screw for the shorter 12-inch lathe. They make a 12-inch lathe that's 48 inches and one that's, I think, 52 or 54. Well, mine's the long one. No lead screw available anymore from Sears. So I ordered a lead screw of the right thread, and I got it a little extra long so that I can make mistakes, you know. And what I'm going to do is I'm going to take that lead screw and I'm going to machine it to be the same size and fit the same length and all that. You know, it's got to have a little bearing surface cut on one end, and it's got to have a keyway cut down it. And that's what today's video is about. And I can tell you something, it's about close to 60 outside, but it's more like 50 in here. I didn't wait long enough for the sun to heat up my garage. Alright, well, let's just get on with it. Alright, you see that long box or tube? That contains the object of my affections. And by my calculation, the lead screw should fit right through the headstock on my lathe, and with a few fractions left over. And I'll be able to turn it. But one of the things I've got to do, I've got to put the 4-jaw chuck in, because the 3-jaw on my lathe is definitely not accurate enough for this kind of work. And I've got to put a support back behind the lathe so the part that's sticking out won't be whipping around in the breeze, you know. So while you guys take a little temporary nap, I'll pop this thing out of the box and get started on setting things up. That tube had a big wooden plug in both ends. It's only got a wooden plug one end now. But that slowed me down there because the staple broke. But I knocked it out of there. And we're down to the lead screw itself, which is neatly packaged in all this nice brown paper, plain brown wrapper, so to speak. So to take the lead screw off of the machine, and I'm going to go handheld, so it'll be shaky here. If I can find the little latch. Alright. So to get the lead screw loose, I just have to pull these 2 cap screws that are in there and make sure that my half nuts are open, and just slide the little booger out the end of everything. And the next step after that, of course, will be to measure it and see exactly what I've got to do on the new lead screw. I imagine anybody that hadn't seen it before, there's probably some new viewers that haven't. You can see that my lead screw there, if I can get it in focus good, see the little ridges are kind of sharp pointed instead of flat like these down here. And that causes a little discrepancy sometimes in my threading. So alright, back to sleep. So like this notch, you can see the lead screw sticking out of the chuck. That's the 4-jaw chuck. And you can see the back of the headstock that lead screw is sticking way out there. So that means I've got to get a 2x4, cut a notch in the end of it, and put it in that vise over there to hold that lead screw so it doesn't whip around in the breeze. That's my next step while you're taking another nap. Alright, so there's one problem solved. Support for the tail end of that lead screw. I can slide that 2x4 up and down in that vise, and I can run that table that the vise is sitting on up and down. So I'm pretty well infinitely adjustable, side to side or up and down or whatever. The next step, I've got some copper jaws already on the vise jaws. I've got to make myself a little adapter to allow me to indicate this wavy moving surface. Okay, so you can see from this side that I pretty much have a flat piece of metal that I have more or less hinged on a rod there above that lead screw. Now I'll take you around and show you the other side. Okay, this is the other side. I've got an indicator pointing as straight down on it as I can, and because that is at an angle, well, I've got the indicator up at sort of an angle, and we're going to try and, of course, zero the thing in. It will move according to the move of that lead screw, which is a bit, you know, off center. And I'm not going to have you guys standing here looking over my shoulder while I do this, because it'll just slow me down. So I'll bring you back when I've got it, you know, chucked up right. I reduced friction on that end somewhat by putting a little piece of metal in the slot. Of course, I had to move everything down a little. But I think that I have reached the point I wanted to. Let's see if that will sit still there. There you go. I'll just turn it on, and you can see there's about, oh, I don't know, probably a half thousandth of run out. This thing's moving less than a whole thousandth, maybe a whole thousandth back and forth. And I think that's about as close as I'm going to be able to get it. So now to take things apart and start doing some measuring and see what I cut and where. Alright, so now I just popped out these two cap screws. And that should let the bracket come out with bearings and everything all on it. I had one guy one time, some viewer saw this in a previous video, and asked me if this was homemade, this bearing mount, and no, this is what came from Sears. It's just not round like the older models were. It's the only thing I can see. Alright, let's see if it'll slide out of there. There we go. It's out. So let me set it down and back you guys up, and we'll get a look at it. Now this guy's about a foot shorter than the new one that I bought, so I bought it like that so I could make a few mistakes if I needed to. You never know. I've done it before. But anyway, let's see. I think I've got a adjustable spanner in my pocket. Everybody has one of those, don't they, in their pocket? And let's see. It's about right there. Of course, it's just a little bit tight to take off. I'll disassemble this. There's thrust bearings on each side of this thing. A bearing here and a bearing here. Of course, they're under very light load, so they may never be, you know, under enough load to have to be replaced. Another little nap for you. So, like I said, there's two sets of these thrust bearings, one on each side of that bracket. This was on the inner side. There's a thrust washer on each side of the bearing, and the other one's just like it. So I've got them off now, and now to measure the lead screw just exactly right. Alright, so I'll be taking measurements on this to get the thread size, the length of all this, and then the overall length of the lead screw. And once I've got this part machined on the end, I'll need to come down to the other end, and of course I'll have to cut the lead screw off because it's much longer than what I need. But I'll have to come down, and this is to set the clutch so that it, you know, if you jam the thing and run up against the chuck or whatever, that it won't damage the gears or anything. This slips in a clutch, and you put a little rod through there and stick out so far and hang a weight on it, and if it slips at a particular weight, it's set right. We'll have to duplicate that. Okay, so we're going to want to know the overall length of this thing. I think that would come in downright handy. So we're going to put this guy down here. Move this ladder a little bit. And that is 49.5 inches. Give or take a 32nd. I dropped that pretty bad. 49.5 plus maybe a 32nd, maybe. Okay, so let's see how long this piece on the end is. And that piece on the end is 2 inches long. So we're going to write that down. Alright, now that I've got all the lengths, it's time to figure out the threads and the diameter here. So let me get more measuring tools. Alright, so here we go. We're going to measure the end of this little fella. See how big it is. I don't know if there's any wear since new. It's 492 thousandths, it looks to me like. Well, I'm sorry, 497. So it must have been close to a ½ inch at one time. Yeah. 497, that's where you can, this thing don't want to focus, does it? Well, the heck with it. Anyway, it's 497. So I'm going to write that down. Find my pen. So I'm guessing that I can come to that same size for the next one without a lot of worry. It probably hasn't got a whole lot of wear, except, well, it doesn't feel real smooth either, so I don't know. Alright, let's find out about the threads. And they're fairly fine, so let's start off here at 16. We'll start on 16 threads per inch. Nope, too coarse. Got 18. No, doesn't fit. I have to move these around where I can get down there. Alright, here's 20. 20 fits. So that's 20 threads per inch, so I need to write that down. Need a secretary, don't I? Alright, so now that we know all the measurements, they were really simple. 2 inches here, ½ inch here, what did I put down? 20 threads per inch here. And I left out something. I got to measure how long it's threaded. So That'd burn it. What did I do with my calipers? Alright, here's the calipers. Good. Let's see how far that thing's threaded. It looks like it's threaded right at 700 thousandths. Yeah. So I guess that'd be safe. Threaded at 700 thousandths. I'll write that down and then we'll move over to the lathe and get after it. Now I guess somebody's going to say, well, how you going to thread that without a lead screw in there? Well, I reckon that I'll probably just put the lead screw back together and put it on here. I'm not sure. I've got a die that will cut that size thread, and it might be better just to go ahead and cut it with a die. So instead of me single pointing it, that might be well advised. This part I can do by hand, I'm pretty sure. So back it up. Again, to cut some of it off. I'm of the opinion I could use a little more speed, so I'm going to crank it up a little more, and I'm going to put you guys to sleep while I'm just turning these threads down to the 1/2 inch size. Okay, I've removed the big threads, and I've got about 90 thousandths to go. I'll get down to within maybe I'd say 15 thousandths, and I'll get a new tool bit, so maybe I can cut a little bit smoother. This metal's hard, and I guess that's not surprising, is it? Alright, back to sleep. Alright, I stopped to measure at 500 thousandths instead of going to 497, and it fits. And it fits pretty nice, so we're not going to go down to 497. We're going to assume that it's had 3 thousandths of wear on it. I don't have plug gauges, so I can't be certain as to how big the hole is in that bearing, but I think that this will work out for me. Now I've got to thread this end here. I made myself a little mark where to stop threading, and so that's the next step. I've got a die to do it with, so I'm going to do it with a die, and I'm sure that'll make as good a thread as anybody's going to get any place. And I think it's actually a Craftsman die. Not certain. I know that Mr. Sears didn't make all this in his, in his office. He had Mr. Atlas do it, so I guess probably Mr. Atlas figured that was about the right dimensions. Okay, I'm going to put this, I got this chuck in back gear so it can't move much. Got the die in here, and I'm going to use the tailstock to guide it straight. And we're just going to slice this little guy as well as we can. I need a little bit of oil on it, I think. Rather than go find the threading oil, I'm going to go ahead and use regular oil. It should do fairly good. It's cutting the thread, obviously. Just need the chips cleaned out. Alright, so instead of dragging this on real long, I'll wake you guys up when I get to the end of the thread. Alright, so the nut fits, the bearing fits, and I think it's time now to take this thing out of here. Go over to the mill, get the vise off, get the mill table cleaned off really good, and set this guy up to cut the keyway. That's probably going to be the most difficult part for me because I've never cut a 4-foot keyway before, but we'll probably get through it. Well, that's all, folks. Y'all try to subscribe if you're not already a subscriber. Leave a comment if you got something to say. And above all, remember, keep on keeping on. Bye now.